Hello everyone, my name is Ada Hurst. In the next few minutes, I'd like to show you how management engineers prepares our students for careers that are not only high impact, but also future-proof in an AI-driven world. This presentation will highlight the kind of information that students normally receive when they come into our sessions at the open houses on campus. In the presentation, I want to cover mainly two topics. I want to give a big picture view of the program and the curriculum, and I'll also discuss the main career paths and the co-op roles that management engineering students take. So just to set the context a little bit, every company today is flooded with data, but the real challenge is how to turn that data into better decisions, smarter systems, and real results. So what are these kinds of decisions that we're talking about? So I want to provide some critical examples to illustrate this challenge, but you can imagine similar cases in any business and in any industry. So for example, how does a company like Uber set the surge pricing in real time? They have to analyze data from traffic, customer demand, driver availability. Or let's take an example in the health industry. How do hospitals decide which surgeries to schedule each day? They have to think about operating room availability, staff schedules, patient needs. Or let's talk about manufacturing. How does an auto manufacturer decide how many cars to build in a given week? They have to think about production and real-time demand and supplier constraints. Another example in finance. How do they balance risk and return in a portfolio? They have to balance algorithmic optimization with human judgment. Let's talk about tech. How does a tech firm decide which features to prioritize for the next technology release? They have to think about get the user research, market data, and also think about engineering feasibility. And finally, one last example, if you think about municipal governments like cities, how do they decide where to install new electrical vehicle charging station? They have to think about cost, accessibility, usage, demand. And so these are all kinds of problems and decisions that are tackled by management engineers. So this is really maybe our definition of where management engineering comes in. In the program, you learn how to engineer, that is, what do we mean by engineer? How to design and how to build systems and processes that enable organizations to drive people-centered, data-driven business decisions and solutions. And so I'm going to start with an overview of the program to explain how the program achieves this. In the program, you'll fundamentally learn to model complex systems and analyze data to support decisions. To achieve this, the program integrates knowledge from three core areas. The first is data analytics and optimization. So this is using data to model and optimize complex systems. The second is software information systems. This is all about designing and applying technology to build solutions, software and analytic tools, solutions that are useful to organizations. And finally, the third area, people, organizations, even economics. This is all about understanding how teams and organizations work and interact with technology in order to create effective change. And so it's through combining all of these that our students learn how to integrate technology, business, people into practical, effective engineering solutions. This results in a curriculum that offers a very unique blend of courses. Students begin their studies with a foundational base with courses in math, science, and engineering fundamentals. This includes an introduction to management engineering and also professional development and communication. Beginning in first year, students also begin building their knowledge in the three core areas that we just talked about. So in the data analytics and operations area, courses cover advanced probability and statistics, optimization, supply chain management, and simulation. In the second area, software and information systems, students begin with basic computer programming and then build their skills term after term to learn about software design and management and the design of computer interfaces. Here I want to emphasize that no prior programming experience is required, and it is only one part of a broad program. Many of our alumni, possibly a majority, do not write code for a living, but majority of them make use of their knowledge of programming because it's so fundamental to the modern digital world. And it's also so important to the increasingly AI-supported systems that management engineering students and graduates are designing and building. All right, and then the third area, organizational science or people in organizations. Students learn about economics, people psychology in organizations, and technology management. And I want to mention this is a very unique feature of our program when compared to other engineering disciplines. It really brings engineering solutions close to the people and the businesses that will use them. All right, so in more senior terms, then students begin to integrate all of the knowledge from the three areas and apply them to the designing of engineering solutions. Design here means identifying and analyzing problems and then developing solutions to those problems. Students can learn about a variety of advanced topics, including machine learning, large-scale optimization, quality management, scheduling, optimization in AI-driven methods for decision-making, analytics, user experience in software products. And then students can also use their electives to specialize. The most popular ones currently in our program are computing, artificial intelligence, statistics, and entrepreneurship. In the program, we're very proud of having team-based, design project-based learning that is infused throughout the curriculum. And to give you some examples, I'll highlight two examples that are basically at bookends of the program at the first year and third and fourth year. So let's start with in first year. In your very first year, you'll dive into real problems through something called design days. These are events that are like hackathons. You work in a team on a problem all day with the guidance and the influence of an industry partner. And these industry partners actually spend the whole day with students providing feedback on the solutions that they're building. And I want to highlight two recent examples of these design days. The first one is with Sun Life, which is a local insurance provider company in Waterloo. And during this design day, students designed life insurance products for patients with chronic conditions. So they had to justify the value and feasibility to senior management from Sun Life in a symposium, in a science fair style presentation. The second was with the Sustainability Office here at the University of Waterloo, which is an opportunity for students to connect with on-campus communities. As part of this design day, they designed different solution pathways to make our campus more sustainable. They had to consider many factors: energy consumption, fleet of vehicles, commuting, waste, supply chains, food systems, and even embodied carbon issues. The second example I want to mention is that of the capstone senior projects, which span 3 terms actually for our students. Students work in teams to design solutions that combine data analytics and optimization, software, artificial intelligence, and behavioral concepts. And they work with industry partners to address different operational challenges that they might have. And so on the slide, you can actually see some of the examples of partners that have worked with us on capstone projects. And we're so proud of our projects that are routinely compete and win both institutional but also national and international awards. And I invite you to actually check out the link on the slide to see some recent projects from 2025, but you can also through that website see projects from previous years. So last year we had some examples, for example, students working with a hospital in Cambridge to optimize surgery allocation in their operating rooms. There's another project where the students used AI to basically build a non-invasive tool to screen for dementia in the elderly. So with all of this said, where does this program take you? What are the careers that it prepares you for? It really all starts with co-op, which is truly world leading at the University of Waterloo. Our university runs the largest co-op program in the world with over 8,000 employers that actively recruit from our university. In management engineering, the program is composed of a total of 14 terms of 4 months, each. So this includes 8 academic terms and 6 co-op terms. So the program is almost 5 years in duration, but that includes 2 years of relevant paid engineering work experience. I want to draw your attention to the scale and impact of our co-op program. In 2024 alone, management engineering students completed 534 co-op terms, with a co-op employment rate of 98% in winter 2025. This translates into up to 2 years of paid work experiences for graduation. And for management engineering students, the average pay by the 6th term is $31 per hour. What's really important here is the big professional network that the students built while they're on co-op. In fact, a majority of them will return to a previous co-op employer for their full-time employment after graduation. And co-op is integrated. There's tons of professional development that is gained through both the co-op program and also professional development courses that students take while they are on co-op. Here's some analytics on what our students do on co-op, what kind of roles they are. So we see an analysis of position titles of over 500 positions over a 12-month period. The most common keywords are related to the 4 Ps: product, project, program, analytics, software, data and AI, and business. And what this really means is that these are roles that vary from software development to product management to various roles in data and analytics and data science, all the way to machine learning or AI engineering. So let me spend a few minutes explaining what some of these typical roles entail. So let's start with a very common path for management engineering graduates, which is in business or data analytics and things like data science. You'll hear this phrase a lot in our department: data-driven decision making. So these roles really are all about turning large, often messy data into insights that companies can use to make better choices. And this varies in fields from healthcare to finance to tech. It covers the full data journey: collecting and storing data, cleaning it, visualizing patterns, analyzing results, building prediction models, and really ultimately using all these insights to guide action. So data analysts and business analysts, so these are sort of the right, they focus on understanding what data is saying, answering key questions, and helping companies make evidence-based decisions. Data scientists, on the other hand, they build the tools and algorithms that are behind the scenes. So they develop models and machine learning systems that can even predict problems before they happen. Together, they help organizations move from just having data to actually using it to make these smarter, faster, and more confident decisions. A really popular career path in management engineering is that of product management, or PM, as students like to call it, a role that really benefits from the blend of technical expertise and people skills that students have. PMs can take on very different kinds of work. Some are deeply technical, collaborating closely with software engineers, for example. Others focus on business strategy and bringing products to market. But at the core, all product managers share one goal: to understand users' problems and then lead the creation of solutions. This is a very collaborative role. PMs connect with designers, engineers, data scientists, business teams to define what a product should do and why that matters. They decide which features to build, set priorities, and keep the big picture on track. And so, in short, product management sits at the intersection of user experience, business, and technology, and it helps teams turn great ideas into successful products. A really popular career path for management engineers is consulting, especially after graduation. This is a very broad field that spans many industries, from technology and finance to healthcare and retail. It's really a great choice if you want variety and exposure to many different kinds of organizations and challenges. Consultants are hired by companies on a project-by-project basis to help solve specific problems or improve performance. This means work can change dramatically from one client to the next. 1 month you might be optimizing a supply chain, the next you're helping design a new digital strategy. But really at the core of all consulting projects is problem solving. Consulting is all about investigating issues, identifying best practices, developing actionable recommendations that make a difference for your client. It's also actually a very people-oriented role. Consultants work closely with their clients, so strong communication, teamwork, and analytical thinking are essential. And so really these skills, analyzing complex systems and designing data-driven solutions, leading change for your clients are exactly what management engineers are trained to do, and which is why consulting is such an important and popular role for management engineers. And finally, I want to just close maybe with one other major career path for management engineering students, which is that of software development. Software engineering as a field is very broad. It includes designing, building, and testing all the code behind apps, websites, any digital systems in really virtually every industry. Our program provides a very strong foundation for this kind of work through courses in programming, data structures, databases, even search engines. Students build a solid technical toolkit, and many students will apply these skills right away during co-op terms. On the job, software developers are problem solvers. They're constantly solving problems, figuring out the best way to design a new feature, and then turning that idea into working code. Some students will focus on the back end, building the logic that powers a system, while others work on the front end. It's all about the user experience. This is work that is both creative and technical, and offers many opportunities to keep learning, improving, and building things for the organizations that make a real impact. These roles actually continue after graduation. We've looked at the LinkedIn profiles of our grads 10 years after graduation, and their roles are for sure more senior, and they're in more leadership positions, but they continue in the broader areas of analytics and operations, product management, software development, and consulting. What's interesting is that many of them are also pursuing entrepreneurial ventures. Some of these, they started while they were here as students, but sometimes they start their entrepreneurial ventures after they've worked for some time in industry. In closing, I also want to acknowledge an important fact, and that the world is changing fast, and every industry is being reshaped by artificial intelligence. We actually get this question often. Will this job, including work like engineering, will it be replaced by AI? Management engineers aren't the ones that are going to be replaced by AI. They're the ones that are actually designing and leading the systems that use AI. Our graduates are actually already driving this transformation in roles like machine learning engineers, technical program managers in AI, and leaders in responsible AI and digital transformation. And on the right of the slide, you'll actually see some of the jobs that our graduates are currently doing in industry, and I just got these based on their profiles on LinkedIn, and you'll see the prevalence of AI in their roles. This degree doesn't just prepare you to work with today's technologies, it equips you to lead in the future, in the AI-driven economy of tomorrow. I want to thank you for listening to this presentation. On the slide, there's a bunch of ways to get in touch with us, to learn with our current student ambassadors, to learn about being an engineer. You can reach out to me to learn more. If you have specific questions about the program, you can reach out to our admissions team if you have questions about admissions. And I hope to see you in person in any of our future in-person events.